In the last video, we looked at the three-player divider-selector method, where each of the two selectors each had two pieces that would be considered fair shares, so everything worked out. They just each had to get one piece. Now, in this one, we're going to be looking at something that might cause conflict, where they each only have one piece that will give them a fair share, and naturally they each want it. So let's see how to work this out. So I made a few changes. So the pizza is the same. We have half of it is cheese, fourth pepperoni, fourth mushrooms. So the mushrooms I drew with brown X's. So person A has stayed the same. He is still indifferent between what he gets. So his mini diagram, no change, $12 for the pizza. Now person B and person C, I've changed what they like. So they both still need toppings, but now mushroom is worth 3 times as much as pepperoni to them. And that's for both. So I'm going to draw a mini diagram. And since they have the same preferences, it'll be the same diagram for both. So this is worth 0, cheese, because it has no toppings on it. And now mushrooms is worth $9. Pepperoni is worth $3. Let's see if that makes sense. They do add up to 12, just like the worth of the pizza. And mushrooms is 3 times as much as 3, which is pepperoni. So everything is working out. Now let's fill in the table. So I'm going to assume here that A has made the same cuts because he has the same preferences, so he could have made this cut. So here's the cut again. Now A is easy to fill in. Everything is worth $4 for him, just as before. B and C are the same. So once we fill in B, we're going to just copy it down for C. So B, how much is piece 1 worth? Piece 1 is still worth 0 because it has no toppings on it. And same for person C. Now, how much is piece 2 worth? So let's work it out. The cheese portion is still worth 0. And we established in the last video that this pepperoni portion that lies in piece 2 is 2/3 of the total pepperoni portion. So 2/3 of 3 is 1. So this is worth only $1 for both people. And since they have to add up to 12, this is worth a whole $11. So we see where the problem is arising now. For person A, everything is a fair share. That's how we cut it. For person B and C, 1 is not a fair share, it's less than 4. 2 is not a fair share, it's less than 4. Only 3, with a whopping $11 each, is a fair share to them. So now, in the stage where they both have to write down their lists of fair shares, their lists are short, consisting only of piece 3. So how to solve this dilemma? So the first step will be to take care of person A. If these two parties can decide on which piece is the least valuable to them, then they can just give that off to person A. So in this case, piece 1 is the least valuable to them. So this, if they can agree on that, and we'll look at a case where they cannot later, but in this case they can, we're going to just give this piece over to person A. So he's done. He has got his $4. He's happy. Now, here's what we do. So we recombine pieces 2 and 3 into a single piece. So we're going to use this orange marker to overlay and highlight the new piece, which is 2/3 of the total pizza. So here's the new piece. And now it just becomes a 2-player game of divider selector. So again, one is randomly chosen to be the divider. So let's say B is chosen to be the divider. So how is he going to divide the pizza? Well, he can do it a lot of ways. But let's just say for simplicity, he cuts the mushroom piece in half. So this is getting a little messy, so let me draw a new diagram here. This is going to be a rough sketch of what we're dealing with. Here's the pizza now. And this is mushroom, this is pepperoni, and this is cheese. So now let's just say he divides the mushroom piece into 2, he divides the pepperoni piece into 2. And his 2 pieces are, this is part of piece 1, this is part of piece 1, and let's just say this is part of piece 1. And piece 2 is what? This is part of piece 2, and this is part of piece 2. Now let's take a minute to note that they are both worth the same. So the mushroom piece was worth how much to them? $9. So since it's cut in half, each is worth $4.50. Pepperoni piece to them was $3, so it's $1.50. So $4.50, $1.50, that's going to be $6. So each piece is worth $6. It really doesn't matter which piece the cheese falls in because it's worthless to them, so they can just put it in whatever piece they want. So each piece is now $6. Now what would happen is the selector, which is C, would choose which piece he wants. Of course, in this case, they have the same preferences, so it doesn't matter which piece he chooses. Let's just say he chooses the blue piece, so everything in blue goes over to person C. and everything in orange will be handed over to person B. Now let's look at how much they got. So person B got $4.50 and $1.50, which is $6. And person C also got $6. So they both got $6 worth of pizza, which is actually a lot more than they were even entitled to, because they're entitled to $4 worth of pizza. So they got $6 worth of pizza. And person A kind of got the short end of the stick. He only got $4. But that's because he cut the pizza in the first place. So we see that even when there's a discrepancy, we can work it out by recombining the conflicting pieces and dividing them in a different way and handing them over to the parties. So in the next video, we'll be looking at something else. We've been having A be the divider for the longest time. We're going to give him a shot to also get a little more than $4.